Here we go again. This is going to be part 1 of 3, analyzing categorical data. Our goal. Our goal is making and interpreting bar graphs and circle graphs for categorical data. We're going to identify what make bar graphs and circle graphs of categorical data misleading. We'll have to cover some foundational definitions. The first definition we were going to cover is frequency. Frequency refers to how often a specific value appears in a data set. So let's say we sample 130 students. Then we ask the students what is their preferred laptop brand. What we have here is that we have 32 students who stated that they use HP brand. We have 28 students who use Apple. We have 24 using Dell, 14 using ARC, 12 using Lenovo, 10 using Microsoft, and all other brands are clumped together in the end here, and 10 students will have the other. We want to make sure that when we add up all of these values, we get back the total of 130 students. So we can think about frequency as just the tallying of the data set. We're going to now talk about relative frequency. Well, relative frequency is showing the proportion or percent of individual values. An alternative definition would be for relative frequency is the ratios of one frequency over the total, because it primarily focuses on percents and proportions. So here, what we've done is taken every one of the values and divided by the total. So in the first row, what we have here is the ratio of our frequency, giving us the relative frequency. And if we were to simplify it, we will then get their percentages. Whenever we think about percentages, we want to always make sure that we add them all up and we are getting 100%. We've seen bar graphs before in our previous class. However, we would like to have a definition of our own. We're going to state that bar graph shows each category as a bar. The height of a bar shows the category frequency or relative frequency. We're going to create a bar graph where each of the category will fall on the x-axis or the horizontal axis, and the y-axis will represent the number of students, where each bar would represent the frequency of our survey data of preferred brands that students use most. Next up, circle graphs or pie charts. Circle graphs or pie charts show each category as a slice of a pie. The area of the slice are proportional to the category, frequency, or relative frequency. We want to think about them as percentages. When we have our circle graphs, we want to make sure that all the percentages still add up to 100%. And they do. Let's go over some common misleading graphs. We're going to first focus on bar graphs. When we're looking at bar graphs, we want to make sure we're displaying the frequency in a nice and clean way. Here we can see that the frequency for HP is 32, and a lot more clearly we can see for Microsoft and others, they both have a frequency of 10. Now let's alter the display of our graph using graphics and converting into three-dimensional graphs. And let's check out our frequency now. When we're looking at HP and its frequency, we can kind of see that, hey, this is actually a lot further off than the intended data. This is a lot closer to 30. Now let's look at what's going on with Microsoft and other types of preferred brands of laptop. This is clearly below the frequency of 10. Both of these might even be considered to be different values. We can maybe even consider that Microsoft might be having a frequency of 9 and others may even have a frequency of 8 because of the way we display the data. Second up, we want to look at bar graphs and the way we scale things. In particular, any irregular scaling or the absence of a zero. Here on the left, we have what we expect a standard bar graph to look like with the zero indicated. Now let's look at a second graph that has irregular intervals and the absence of the zero. In this situation, we're starting at 9 instead of 0. What this tends to do is emphasize certain things over other set of information. Let's see what we mean by this. Let's cause in a more extreme case where we are setting our starting values to be 10. This would cause the brands Microsoft and other brands to be eliminated from our bar graph. And this would cause us to emphasize on the other brands to be more important than what they really are. The last misleading bar graphs we want to take a look at are display narratives, meaning add a lot of colors to distract us from the information we want to display. Also, what we can see here is the positioning of our information. We can see that there is a pattern where we are arranging our preferred laptop brand in a descending order. However, by changing what we display at the very end, this can emphasize that the last brand or the last placement of this brand can be more or less, typically less important than the rest. All right, time to look at circle graphs or pie charts. Generally speaking, we want to keep it simple. Here is the circle graph based on the original data. We surveyed students on their favorite laptop brand. We can see that each of the slice takes up the appropriate amount of area. Now let's look at a misleading circle graph, in particular, a 3D circle graph. Let's focus on the last two categories, Microsoft and other. They are both supposed to be 8%. However, the area for the other category seems to be larger than the Microsoft category. Let's look at another example using the exact same 3D graph. Let's look at Dell. It's supposed to represent an 18% area or slice of the graph. However, if we compare it with the 25% HP category or the 21% Apple category, Dell seems to represent the same area as the other two at 18%. This causes a mix match in displaying the information we want. So the key takeaway about common misleading graphs are: one, we have to be careful about three-dimensional graphs distorting the data. Two, omitting baseline, meaning the zero line, in the intervals, and using inappropriate or irregular scales. Lastly, altering and displaying data to imply a specific narrative, meaning to imply something that really isn't there. Like and subscribe. And when we come back next time, we'll look into the second part about analyzing categorical data.